Hello everyone, you are welcome to my YouTube channel. Next example here is I will just show what we're trying to do here. With Markdown, we are trying to we want to load in data from from directory. We want to load data from directory. So we load the data from the directory, and how do we do that? We have the read CSV or read XLS or read Excel, but I often prefer to use the read CXV. So here I'll call it data frame df equals pandas.read. I have this my directory, same directory where I saved the output result. I have another CSV known as population growth. I will link a link of this file in the description um, of this video so you can easily download it as well. So what we'll do is we'll call pd.read and we'll pass in the location. If we run this cell, what do we have? We have loaded our data frame into our namespace. Next, let's see what data looks like. So we print df.head. So it gives us the first five item of that data. You can see it has what column? Series name, series code, country code, and then you can see the other column of the year. Okay, this is talking about population growth of countries, okay, in the world, and you can see ranging from 2000, 2001. Now you notice here that we have the year, and then we have another YR year 2000 in brackets. Down this video, we'll see how we can do what now? Clean up these column headings and return them as just 2000, 2001, 2002, 2003, so that it can be easy for us to do data visualization using that column heading. So you can see it runs until 2015 with all the values there. Okay. Next is you can call df.keys. What am I doing here? I'm going to see all the column headings. That's the keys. So if you run this, it returns all the column heading. You see series, and then the D type is what object. Okay, they are just objects. Okay, so that's all the column headings that we have. Then next, like I told you here, I want to use the iLock. So I want to using iLock, you have to use an index. Okay, you can decide to look at the first item. Say I want to look at the first item, okay, which is the first row, and the third column. Two is third. 0, 1, 2. Two is third. If we run this, what we have, it tells us Afghanistan. Okay, but if I want to look at all of the rows of that column and we run it, you see it returns everything. It's about 217 in number, and then you see all of them, and here it is condensed. Okay, you can likewise still call head on this as well. Same, it returns the first five items. There's a lot you can do here. So this is just one of them. Um, that is done. The next here is to what now? I can also use locate. I know country code is one of the column. So here I want to use the lock. So remember the two notation, the lock LOC. Okay, you have to use the column heading as strings, pass them as strings. You can pass in multiple strings. I will show you that very shortly. Then the iLock uses indices. So you have to pass in the index of that column. Okay, so let's run this. You'll see what we have. It returns only because I'm picking just the country code. If you want more than one column, you can do that. All we need to do is to pick this bracket, country code, and then we want country name, and you close it. Right? All the rows of these two column, country name and country, let's see, yeah, country code and country name. It's correct. We run it, it returns the data frame of it. Can you see the country code, country name? Now it returns it the way I've queried that data frame. If I query data frame with country name before country code, it will return it that same way. Okay. The next thing we do here is that we can decide to get some information about that data frame. So I print df.info, right? .info. You see, it gives me a total information about that data frame. Here you're going to see if you have some null or what we call some non-zero values, or we have missing values, or we have null values. When we say null values, we refer to them as missing values, NA values. So here you see the series names. It picks out each of the columns and then returns the length of that column, the type of that column, as well as if that column contains a null item or not. This is just giving us the full basic information about the data frame. It also goes ahead to tell us the memory usage, how large that data frame is. So that is what we have. The next thing we'll talk about here is we can also check if you are not sure. You can do something here. If you're not sure, you can check if your data contains some missing values. Now, if you have some missing values, then you have to decide how to handle those missing values. Now, rather than looking through this one after the other, you can easily use a method or a function in the Pandas library, which is df.isNA. If you click this, it gives you a full table. It returns the data frame, and you see where we have a missing number, it returns true. Else it returns false, 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 false. Sometimes it's often difficult to look through this because the values are condensed at this point. So you cannot look through all the individual values. So what do we do? We can simply use the info. Okay, the info gives you a summary, and then if you have a missing value, automatically it will be spotted there. So you know which of the column, okay, has missing value, and then you can replace the missing value in place. Okay, we'll show that very shortly. So the next here is what we often refer to. It gives you some statistical information. The info doesn't give you statistical information about the data frame. It gives you just some, basic information summary of the data type, the number of the items in each of those column. But when you use .describe, it gives you statistical information, which is like exploratory data analysis. So if you run this cell, it gives you detailed statistical information of what is happening of your columns. Sometimes it's not neat to print it this way, so you can transpose it by putting .t all over here. So there it returns the count, which is the number of items for each of the columns, returns the mean, the standard deviation, the minimum, the 25% percentile or 25% percentile, okay, the 50th percentile, the 75 percentile, and the maximum of each of those items for each respective column. You can see it details it from 2000 until 2015 for each of these statistical. So you can use here, you have a glimpse of the distribution of this data, the measures of central tendency, and the skewness and all of that. So you can easily, pick that out without having to look through each of those items in the data frame. The column headings have this bracket and wire 2000. I want to remove them and replace them with just the year values, which are strings. So how do I do that? What to do here is I'll come here and make a copy of the data frame. If you use the data frame directly, every changes you make to that new data frame is affected in the old data frame. So to avoid that, so I make a clone or a copy of it, and that will give me new df equals df.copy. At this point, I have a new data frame that I've copied. Let's see, print the head of the new data frame. You see, same data frame, same data frame. Next, what I'll do is now I'll create an empty dictionary of columns. I want to pick all the columns, okay, and then map every of those old column to a new name because I want to rename the column. So to do that here, I'll create a dictionary, empty dictionary, and I'll say for column in df.columns, Once we do df.columns, remember we showed that earlier when we did df.columns, it returns all the column names. The same thing as calling df.keys. Okay, returns all the column names. So I'll do df.column. So for column in df.columns, now if you find an open square parenthesis and a closed square parenthesis. That's what I'm looking at because I want everything inside the open and closed square parenthesis to be thrown away and replaced by all values before it. So if you find this in this, what should you do? Create a dictionary. Create a key, the columns. Okay, create a key of column, right? And what do you do? Split those columns, split it, and return the first item. Split over, an empty space. There's a space before 2000 and that. So split it and then return the first item. So what it does is that it splits column into 2000, this bracket, and the YR 2000 and the last square bracket. So where you can't find such, else just pick the column directly. It means it's right. And why did I do that? I will give you an insight why this code is that way. Look at the first name here, series name. There is no square parenthesis there. Followed by this, followed by this, followed by that. It's until you get to the this is 0, 1, 2, 3, 4 from the fourth, fifth until the last that you have it. So for these ones, you to just pick those names that way and map it and keep it in my dictionary. And then for those ones with the square, open square, and the closing square parenthesis, what it does is that they just pick these values before it and throw away those ones. That's what this code does here. So if I run it, what do we have? Run it. Let's print what are my dictionary columns. If I print my dictionary columns, you can see it. So you can see in my dictionary columns, series, code, you can see it. So there's a mapping of it. So it maps, you can see it maps, that's the old column name. I'm mapping it to a new column name, old column name to a new column name, just like that. So now what will I do next? I printed so as to verify that I have the right thing. What will I do next? The next is that I will now call this new df and rename the columns. Rename columns equals columns. I'll rename by passing in these dictionary columns, and I'll ask you to do it in place. In place means it is affected. It is affected. Uh, in place is an in place action. If you don't call in place to be true and say in place is false, by the time you print the new f, for it to be replaced, but when you print the new f, it is not affected in that new df. Okay, the new data frame. Okay, it's just an operation run and you can see it, but it doesn't change the content of the new df. So I want it to change, so I'll call in place to be true. So if we run this, I have my data frame in there in the namespace. Let's print the new df, the columns of the new df. If we print the columns now, you see the columns have been altered, right? They've been altered. So now we can do some filtering. Um, for example, you want to train a machine learning model. I actually don't need, I just need the values from 2000 until 2015. I don't need the series name, series code, country name, country code, right? Or I want to retain the country code and throw away the series name, country name, and series name. I don't need them. So what will I do? I'll simply call another method in Pandas, which is drop, right? So I'll call filtered df now because I want to make a new DF different from the new DF. Okay, so I call filter DF a new, the filtered one by removing those respective columns. New DF dot. Then I will drop all of these columns. I want to drop this, and that. And what is the axis? Drop them by row. All the rows of it. So if you run this, right? We can check something there. Let's check if filter df, has some missing values. So we print these. You can see it's false, false, false. We now have country code, and then we have the year is false, 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 false. No missing value, right? So if we have missing values, we can fill them with fill NA For example, assuming we have missing values, you fill every missing value with zero, specify the axis, and you ask what method of operation in place, but we don't have this. That's why I commented that out. Likewise, we can drop NA. If you don't want to fill NA, what to do is to drop totally anywhere we find the missing number. We drop all the values, the corresponding values across the row, okay, and say in place operation is true. But here we don't have such situation, so I've commented that out. Let's print filter df and let's see to see the result of our filter df. Let's check filter df.head. Let's just print the first 5 items and we run that. What we have, that's filter df. Right. The next we are going to do here is to do what now? Let's do something here. Let's find the mean of this filter df. Okay, I want to find the mean. Here again, I print and I apply in the passing the function and specify the axis. Okay, right axis is 0. Let's see. So I want to filter df and find the mean for each column, all the rows. I want to find the mean. Let's see. I'll run this. Ouch, I have a type error. Okay, whenever we get such error like this, we don't get scared. What we should do is to quietly go down, 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 and down, and down, and down. Lot of information. What is it saying here? It's type error. You can see that the first column of the DF has these strings, blah, 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 blah. They are strings. Remember, they are basically the country code. So we cannot find the mean of strings. That's why it's throwing up the type error. So how do we solve this problem? How do we solve this problem? To solve the problem, we come here before we apply the apply method. We select every column of the DF except the first one. So all rows, the first column of the DF is what is. I want to use the ilock. Okay, so first of all, we'll come here and use dot ilock all the rows, and I don't want the first column, which is 0, so I start from 1 until the last. Don't put -1. If you put until -1, you would exclude the last column. But if you leave an empty, just column an empty, it means it takes from the first, okay, which is from the second until the last. The first is 0, the second is 1, until the last. And then we apply axis 0 for all the rows. If we run this, we'll have our results. So for every year until 2015, you can see the float type is 64. Lastly, before I end this video, we'll just describe the data. So let's get the statistics of this filter data. Okay, you run this and I transpose it. It gives me the statistics, tells me the counts, the mean, the standard deviation, the 25, the 50th percentile, the 75 percentile, and the maximum value. You can get the info as well by calling filtered df.info, and gives us the information about it. You can see data type and all of that. So this is just a rundown of a brief of what we can do with our data frame. I want to save these results. So I will call filter df dot. I want to save it as a CSV, right? So my location is here, data, and the file name. I will check my file name first. The file name, I call the particular file name. Quickly, let's see what the file name is all about. Population growth, right? So I have population growth or CSV. I will just use same name, population growth, and then I will do a bit of modification, population growth, and here I put version 2, v2.csv, and then close. If I run this cell automatically, it is saved to this specified directory. And then you can open that to look through the data. So with this, we have come to the end of today's video. Please like my video, share this video, and also subscribe to my channel. And when you subscribe, don't fail to click the bell icon to get notified whenever I drop new videos. I will see you in my next video. Bye.